Hello everybody, my name is Ulrich and welcome to our second installment of vSphere with Tanzu. In this video I will show you everything around cluster lifecycle management. We will create our own clusters, we will modify these clusters, we will scale these clusters, we will upgrade the clusters, as well as the supervisor cluster. So let's get started. We start with the demo environment that we used in our last video, where I set up vSphere with Tanzu and NSX Advanced Load Balancer. If you haven't done so, please have a look at the video in the description below. We will use the namespace that I already created, as you see on the screen, and I have a developer user that will create the clusters as if you're a real developer during the video. So my developer is called Cody and he got the edit privileges for this namespace, and that's what we will use now. And now we're switching to the CLI. So if you want to follow along everything that I do, please have a look at the GitHub repository that I'll link in the description as well. There will be all the example files that we used during this video. So the first thing that we need to do is to log in back into our supervisor cluster. And in my case, that's this. So kubectl vSphere login. So using the vSphere plugin and using my user Cody to run through the developer experience. So once we are logged in, you can see I've got the different contexts that I can use. And here's our test context that I will use. And I will use kubectl cdx to switch into that context. And I will link you the extension or the plugin for kubectl, the cdx plugin as well, so that you can use this as well. It saves you a lot of time to switch between different contexts and get the hang of it. Okay, so what we need to know now is we as a developer just got the info that we have our own context that we can now use, and what we want to do is we want to create our own TKC cluster, so Tanzu Kubernetes Grid cluster. And to do so, we need to have some basic information that we will use. For example, we need to know which Kubernetes version we want to use, or which Kubernetes version is available to us. We need to know which storage class we can use, and we need to know which VM class we can use to create our cluster. So we will start by getting the information about which Tanzu Kubernetes Grid release we have. So that's kubectl get tkr, and this will list all the Kubernetes releases that we have. And it will also list all the upgrades that we have. And as you can see now, the latest version that is available to me is the 1.21.6 release. And this is due to the fact that this is the version that the supervisor cluster is running. And you cannot have a newer version than the supervisor cluster. Once we do an upgrade at the end of the video of the supervisor cluster, we will have a newer version, the 1.22 release, available as well. And that's what we will use to upgrade our cluster. So to create our Kubernetes cluster, we will write down this version name, and that's what we will use in our YAML file. As you can see, there are two types of names, basically, and you see that these two look different. And there's a reason for that. So if we do the same command and add the show labels as well, you can see there are a ton of different labels, and what you need to know is that there are labels that are that specify the operating system name, and there are two types. There is either Photon-based or they are Ubuntu-based. And so if we do again kubectl get, and now we filter on based on that label, OS name equals Ubuntu. Yeah, we need to add the TKR as well. And you see that there are the two versions that I mentioned previously, and these two are Ubuntu based. For the demo of this video, I will use the Photon-based images. So now that we know the name of the Tanzu Kubernetes version that we want to use, the next step will be that we do that we find out which storage class we can use. And this is a little bit different than you would normally be used to. So normally what you would do is kubectl get sc for storage class, but the storage class object is cluster bound. So if I execute that command, I will get an error. As you can see, I'm not allowed to get the storage class. As I said, it's cluster scoped, and we only have access to this namespace, so we cannot request this object for this namespace only. So what we need to do instead is we need to do a kubectl describe namespace tkc test, and this will actually give you the storage class name as well as the storage quota that we set, or the overall quota that we set in the vCenter. So what our VI admin provided us to use. So you can see there's the CPU limit, and there's the memory limit that was assigned to our namespace, and there's the storage limit that was assigned to our namespace. And that's all the information that we need. So currently nothing of our storage is used, and all the other limits are not used. And so what we need to do is we need to note down the storage class, as this is needed in our Kubernetes deployment file as well. So the last information that we need to provide in our YAML file for our Tanzu Kubernetes cluster is the VM class that we want to use for our control plane as well as our worker nodes. So to get that info, that is kubectl get VM class. And this will list all the VM classes that are available to us within our namespace. And you can see these are the different namespaces and VM classes. Don't worry too much if you don't have a medium CPU version. That is a storage class that I created, and we will cover this as well. So in the Git repository that I'm linking in the description, there is a folder to cluster management, and in there we have our cluster file that we will use, and I will show you it here. So this is a base version of our cluster configuration that we will use throughout the video. There are additional files in that folder that add additional features like proxy configuration, additional storage, which will be covered in a minute. But this will get you started to easily create a cluster. So what do we need to specify in our cluster configuration? It's basically this, and the default storage class is already optional. So I'll also link the full description with the entire optional settings or the description of the YAML file in the description. And what we need to do is we need to give the cluster a name. The namespace is optional. If you don't specify the namespace, it will create the cluster in the context of your current context. You need to specify the control plane, the number of control plane nodes. This can be either 1 or 3. For high availability, you would go for 3. In our demo purpose, I will just use 1 control plane. You need to specify the VM class, so we will use the VM class that we wrote down and checked previously. The same goes for the storage class. For the storage class, we need to specify the name of the Kubernetes release that we want to use. Then we need to create a pool of workers. There can be multiple worker pools, but for simplicity, we will only use 1 worker pool with 2 workers in there. This is the medium size for the worker nodes itself. Storage is the same as for the control plane, as I only have 1 storage in my demo environment. And the same version for the, obviously the same Kubernetes version for the worker as well. And the only optional setting that I use is the default storage class. This allows us to create persistent volume claims within our cluster without specifying the storage class. So this is the default storage class that will be used if you create a persistent volume. And that's it. So once we have this set up, we can say kubectl create -f test cluster, and this will create our Tanzu Kubernetes Grid cluster. Okay, so to see how far our cluster was actually built, we go to kubectl get TKC, Tanzu Kubernetes Cluster would be the long version. And what you can see now here is that I created the simple cluster name on the control plane as a single control plane. The worker will show up in a second. The TKR release, how old it is, and that there is an upgrade available. So I created the 1.21.2 version, and our upgrade would be 1.21.6. So if we call this method again, you can see it already provisions or tells us that there is 2 workers in here, and then we have also the status flag of the worker of the cluster as well. If you want to get more details about the current state of your cluster from the CLI, you can go to kubectl describe TKC and specify the simple cluster, and this will give you a detailed state of the current nodes. And what you can see here is scaling up the control plane to 1. So we specified only 1 control plane. There's currently only 0. And same goes for the worker nodes. And as you can see here, the worker nodes are still also at 0. And we are waiting for the VMs being created. If you want to list your Kubernetes virtual machines that you have, is you say kubectl get virtual machine, and this will show you that the control plane VM is being created, and it's 2 minutes old. And yeah, the current power state is we don't have enough information yet about the VM as it's still being created. Moving to our vCenter to have the VM admin role, you can actually see here's our TKC. There's a cluster object that's being created. You can see that the VMs, the OVAs are being deployed, and the control plane node is already seen by the vCenter, but it's not functional yet. So we are waiting for the control plane to be able to power up, and then we get additional infos on the CLI as well. So once the VM is actually available, and if we execute the command again, we can see that the power state is powered on. And if we now describe our cluster again, we can see that we are waiting for the kubeadm init process. So the cluster is being initialized, and we are still waiting for that process. Once that's finished, we are waiting for the workers to being created and joined to the cluster. And that will take a couple of minutes again. And once you can see that the API, so the load balancer IP for the Kubernetes API is already being created. And so our control plane is already reachable. And now we are waiting for the full cluster to be creation completion. So after a while, our cluster will be finished, and if we now execute kubectl get TKC again, we will see that the cluster is completely ready, and we can use the cluster and log into the cluster. That will be our next step, to log into the cluster and then experiment a little bit with the cluster. So if we now do a describe of the cluster again, you will see that the cluster is completely ready. It will show you that there's an update available, and that the last change that was there is from the creating phase into the running phase. On top of it, you will get, if you scroll up, you will get the status of the IP address, as I already mentioned, for the control plane. So the load balancer IP that you got, you get the status and the version of all the add-ons that are being installed during cluster creation. So which version of the CNI, so in my case Andrea, was used, which version of the CSI was used. You can get all these information directly from here, as well as how the cluster was actually created. So these plugins, so the YAML file that we basically specified is shown here again. And now we can use that cluster directly. Okay, so once we now have the cluster up and running, we can log into the cluster, or we can scale the cluster. So as the focus is on the cluster lifecycle management, our goal is now to scale the cluster. So there are two ways how you can do this. You can either modify our YAML file and apply that YAML file, which is the preferred way, at least for me, because then you have a documentation on your Git repo or whatever you're using that replicates the state that the cluster is actually in. Or you could run kubectl edit to actually edit the cluster directly. So if we run kubectl edit tkc and say simple cluster, and there you have the cluster config. You could change the control plane size. And here I will explain the difference or the different things that are allowed. You can scale up the control plane, so you can change the number of control plane nodes from 1 to 3, but you cannot scale it down from 3 to 1. So once you scale up your cluster, it needs to stay consistent with 3 nodes. Then the other thing that you can do is you can change the VM type. So currently we have a best effort small. We could change this to a guaranteed small, or we could change it to a best effort medium, large, whatever fits your needs. Same goes for the workers. So for the worker count, we could change this from 2 to 3 nodes, as well as from 3 to 2 nodes. So for the workers, we are allowed to do a scale down, whereas this is not allowed for the control plane. We can scale the VM class, so we can go up with the VM type, and as well as we can go down with the VM type. So we can go from a best effort medium to best effort large, or a best effort small or X small, depending on your actual needs. So what we will do now is I will fix it in the YAML file, and we will do it in the YAML file just to be more consistent and to have a better view of what we're actually doing. So we will change the cluster YAML file to 3 workers, change this to 3, save the YAML file, say kubectl apply this, and so what you can now see here, if we do a kubectl get tkc, we can see that our cluster has now 3 workers, or is expected to have 3 workers. It's now in the ready state is now false, as we are adding a 3rd worker to it. And if we go to the vCenter, you can see there's the 3rd worker that is being applied to the cluster. You can see that is copying the OVA. And once this is finished, we will have a fully functioning cluster again with the ready state. So the next step will be to change the disk size of the cluster, which is not really possible. So each VM type includes a 16 gigabyte disk size. So this can get you in trouble if you have a lot of container images within your cluster, and if these images are quite big, because the containerd process will basically store them locally on the local file system, and you run out of these 16 gigs quite easily, and that will result in disk pressure and an overall unhealthy state of your cluster. So to circumvent this, you can mount additional disk space into your cluster, and I prepared another one, volume. So this is another deployment file in our case. And what you see now here is that we added a section to your worker pool, to the worker nodes, and we named it containerd conveniently. And this is the mount path of containerd. And we specify the additional capacity that is needed for our storage. And if we hit apply now, we are able to actually execute this and have the cluster, and say, okay, kubectl apply test cluster volume. And this basically will now add the additional volumes to your cluster, recreate the worker nodes, and add the additional volumes to your cluster. This will take a few minutes as well. And once we are finished, we continue with the session. So if you look at the vCenter again, you can see now that there is a new worker being created. So it's doing a rolling upgrade throughout your cluster, create new VM, a new worker VM, with the additional storage, join that to the cluster. We'll do a node run of the original node and rotate through the entire cluster. Once we have this completely finished, this takes a few minutes in my environment, we can continue with the next step. Okay, so once the cluster is ready again, we can get kube control get tkc, and we'll see the cluster is ready. Now the difference is we can actually list the additional storage that we created, because everything is Kubernetes, so we can get them as persistent volume claims. Kube control get pvc, and you can see here are our 3 nodes and the 3 volumes, each volume for 1 node. And the 25 gig is the amount of storage that we actually requested. And if we now do a kube control describe namespace tkc test again, you can see that there is the amount of storage that is actually being requested, and we can actually see that it's below the limit that we set for our namespace. So that's how far we are right now. And the next step is to actually add a proxy configuration. So in most cases, if you're in an enterprise environment, you probably will have a proxy in your environment to reach the internet. And the proxy on top of that will have its own certificates, because if you use a HTTP and HTTPS specifically, you will need to have the company certificate within your cluster so that the internet will work, so that you can reach the internet through that proxy. So the next configuration file will include these options, and I explain this in a little bit more detail. So there are actually 2 ways how you can change the proxy configuration. So either this is a global config, where it will be added to every TKGS cluster that you create, or you can create it on a per cluster basis where it's part of the cluster configuration. So we will look at the first part of the global configuration. So for that, you do kube control edit TKG service configuration, and then it's TKG service configuration, and have a look at it. So to add the config for the proxy, you add it directly taken from the VMware website. So please feel free to modify this for your liking and for your environment. You need to add the HTTP and HTTPS proxy. For the no proxy settings, make sure that you obtain the IP address of your load balancer. You do not need to add the workload network. So what you need to add is the load balancer network, the network workload, and the management network, so that you're sure that there's no proxy involved for these networks. And the port and service siders are also added automatically. Localhost as well, so you do not need to add these to the node proxy list. If your cluster now, or if your proxy now is using a CA that you're controlling, in that case you need to add the certificate as a base 64 encoded string here as well, and you can add additional certificates on top of that. So for example, if you're running your own Docker registry, and you have an internal registry which is also signed by your CA and has its own certificate, please add this here as well, because otherwise the container daemon will not be able to pull images from your internal container registry. So add this here as well. And if you do so, the certificate will be automatically added to all clusters that you create afterwards. And this is an easy way to update your global configuration and have these certificates and proxy settings added to all clusters that you create. An alternative approach is to add this to your specific cluster, and this allows you to also override these settings. And that's what we will do next. So the next step is to actually change our cluster via the cluster configuration file and add the specific information for our proxy, and add the certificate as well. So if we have a look at our test cluster proxy configuration, so that's the last configuration that we use, you can see I didn't change anything in here. I actually reduced the replica back to 2, And we still use the same containerd configuration that we did before. And what we now did is we added a network part, and we add the proxy configuration. And here's the proxy for HTTP as well as HTTPS. I add the no proxy configuration here. If you change the service domain, which is an additional flag that you can set from the default value cluster.local, you need to change this as well to make sure that the proxy is not listening on that. And here's the base 64 encoded certificate for my HTTP proxy. And I add an internal harbor certificate as well, which is here. And now if we apply this, our cluster will have an HTTP and HTTPS proxy set with the additional certificates so that it can trust our internal harbor registry. And this is more like a corporate setup that you would probably use in your environment as well. So kubectl apply. And now it will update the cluster, and we can have a look at the cluster again. Kubectl get TKC, and you can see the cluster is not ready again, and it will take a few minutes to get this up and running. The big difference between the previous changes is that because we now add a certificate, and the certificate needs to be added to all nodes as well as the proxy configuration, this includes a new creation of the control plane as well. So be aware of that. So if we go to the vCenter, you can actually see that it's changing the control plane as well. So we create a new control plane. Our old control plane is still running, but this change will also trigger a recreation of the control plane as well, and not only affect the worker like the previous change that we did where we added the storage. The storage configuration change only affected the worker as we only applied the storage configuration to the worker VMs. You could also add this to the control plane and add, for example, additional storage for etcd. But in our example, we only added it for the worker VMs. And if you change the certificates or the proxy settings, this will affect all VMs, including the control plane. So be aware of that. Okay, so let's have a look at it. So our cluster is up and running again. And the only thing that's really missing now is to do an upgrade. So you can see here now there is an update available, but we cannot directly use this because if you look at this again, the name of our Kubernetes version slightly differs. So we created the 1.21.2 version for our cluster. And what we now want to do is have a look at what the name of our update will look like. So kubectl get TKR to Tanzu Kubernetes releases again. And what we see here now is this is the version that we want to do. So have a look at it. This is the version tag. But the corresponding name that we need to use in our deployment, or if we edit the cluster, is actually this one. So we will copy this one and edit it in our YAML file. And then we are able to do an upgrade. So back to our cluster, I also provide an upgrade YAML file. And if you have a look at it, it's the same configuration as we did before. So it includes the proxy configuration, it includes the additional storage for our containerd. And as you can see here now, I added the two names for our references. And this is what we will now use and apply to our cluster. It will recreate everything. It will recreate the control plane. It will recreate the worker pool. Everything is a rolling upgrade. So it will create a new VM, join that to the cluster, and upgrade, start the upgrade procedure. So what we do now is kubectl apply -f and do the upgrade. And this will do the entire upgrade of our cluster. And we will jump right to our upgraded cluster in a minute. So if we now run our kubectl get TKC again, we see that our clusters are upgraded. We have now the 1.21.6 release, and it doesn't show any updates anymore. So our cluster is upgraded, and we are good to go. So basically, we did now everything we can with the cluster. The only thing So basically we did now everything we can with the cluster. So we upgraded the cluster, we resized the cluster, we added additional storage and proxy configuration. So the only thing that's missing from the cluster lifecycle management is actually to delete the cluster once we do not need it anymore. And to do so, we say kube control delete tkc and refer to our test cluster, and this will completely delete the cluster, remove the VMs, remove the persistent volume claims, we'll remove the load balancer, and the namespace will be completely empty afterwards. This is a blocking task, so once it actually finishes, you will see it, and this will take a couple of minutes, and we have completely cleaned up our environment again. So as you can see now, the deletion was completed, and if we go back to the vCenter, what we will see here now is that our namespace is completely deleted and nothing in there, and now our vAdmin could basically delete the namespace and get rid of the entire environment. So we basically did everything we can with the Tanzu Kubernetes Grid clusters, and the only thing that is missing now is to showcase what we can do with the supervisor cluster itself. So how does an upgrade work with the supervisor cluster? So we go back into the workload management, and here we go to updates. And to see an update here, you actually need to have vCenter update. So the upgrades of the supervisor cluster are bound to the vCenter version. I already did an upgrade of the vCenter version. And what it will show me now here is that we can go from 1.21 to 1.22. And basically all you need to do is you need to select the version that you want to go for the upgrade. And you can see I could go for a minor upgrade, but I want to do the next version. I say apply update, and this will completely upgrade my Kubernetes cluster to the next version. And you can see here now it's starting the upgrade. And if we go to the inventory, we will see that there will be a new supervisor cluster VM that joins the supervisor clusters, so that we have an additional VM there. And it will do a rolling upgrade. It will join the new VM. You can see here now it's starting the upgrade process. And there's our new VM. It will increase the number. It will boot the VM, join it to the cluster, do a node drain of one of the old VMs, and roll through the entire cluster. And once this is finished, we have an upgraded cluster. Be aware, depending on the update, this can also trigger an update and recreation of your entire guest clusters. So all your TKC clusters can be updated depending on what's included in the update. So this may take a couple of time, may take some time. So I will skip right to the end when this is basically finished. So if we go now to the CLI again, so you can see we have the 1.21 release here as the newest version. And if we now do a kube control get TKR, you can see that the latest release is now the 1.22.9 release. So it was already in our content library, but it was not shown as it was not compatible and not available to the 1.21 release of our supervisor cluster. And you can see that some of our old releases have been deprecated. So the 1.17 release have been marked as not compatible anymore. Same goes for the 1.16 releases. So the latest version that you need to run is 1.18, and the newest version is 1.22. Okay, there's one thing that's missing, and basically more as an extension or the tech preview. So I put it at the end, and that is not only self-service of the cluster, but also self-service of the supervisor cluster namespace. So for you to be able to use this, your vAdmin needs to go into your vSphere cluster that has Tanzu enabled. We go to General. There is a namespace service, and here you can enable the namespace self service. So what you now need to do is you need to set some limits. That is the default limit for that namespace. So you basically create a template, And let's say we want to have 8 gigs, 8 gigahertz. We want to have 24 gigs of RAM, and let's say 100 gig of storage, which is the default network that you want to put it in. It's our workload management network, and which storage policy do I want to use is the Tanzu storage policy, and you can see the details of that storage policy. Yeah, it's an NFS in my case. So next. So now we need to select who is allowed to do this, and I want to do it with the same user I used so far. So let's search for it there. So now Cody is allowed to do it, or you could select a group. Next, have just confirmed this and have a look at it. Everything's fine. Hit finish, and now it will enable the self-service of our for namespaces. And there it is. So it's now enabled. So you see the details, and basically there's a link again to our download page, the Supervisor Cluster Namespace service, and we now are able to actually use and create it and switch to the CLI again. As we upgraded the Supervisor Cluster, there will be a new version of the plugin for kube control, so we can download it and use it again, and I already did this. So switching back to the CLI, now that we have the permission to create our own namespace, we will use the namespace self service, kube control create NS, and we call it just self NS or self namespace test. This now created the namespace, and if we go back into the vCenter, we can see that there is our namespace. We can see that there are our limits. Our storage policy is applied, and the difference is that we are not now the owner of that namespace, and not only in the edit role, but we are in the owner role, and we can create and delete this, and that's it. So this marks the end of our tutorial. We did everything around the cluster lifecycle management that I wanted to show you. If you liked the session, please leave a thumbs up, subscribe, and leave a comment if you have any questions around what we did so far. And in our next video, I will show you how to install the Tanzu packages into one of your clusters.